Shelley, why don't we exchange our pets? You give me some of your butterflies, and I'll give you some of my beetles.
Okay, Tammy. I have 15 butterflies in all, but right now I have only 5 in my jar.
Aha! I have 9 beetles in all, but right now I have only 3 in my box. So I'll give you 3 of my beetles.
Have a heart, Tammy. I gave you 5 butterflies and you're giving me only 3 beetles. That's not fair.
Come on now. Why are you so angry? You had 15 butterflies, while I had only 9 beetles.
What is going on? Why are the two of you fighting?
Look, Daddy, Tammy is cheating again. He has given me only 3 beetles in exchange for 5 butterflies.
I gave her 3 out of 9 of my beetles, and she gave me 5 out of 15 of her butterflies. I think I have been fair. Haven't I, Dad?
Ah, now I understand. Proportion to the rescue!
What are you saying, Dad?
Let me explain. Actually, the ratio of the number of pets exchanged between you should be the same. Shelley gave 5 butterflies out of 15, so the ratio of the number of butterflies given by her is 5:15, or 1:3. Tammy, on the other hand, gave 3 beetles out of 9. So, the ratio of the number of beetles given by him is 3:9, or 1:3 again. Since both the ratios are equal, it is a fair and proportionate exchange. Tammy hasn't cheated you, Shelley. Not this time.
Tell us more about proportions, Dad. Are they like ratios?
Well, proportions are equivalent ratios. When two ratios are equal, they are said to be in proportion. Proportion is denoted by the signs as or equal to. For example, ratio 5:15 is proportionate to ratio 3:9, and it is written in the manner shown. It is read as 5:15 as 3:9, or 5:15 is equal to 3:9. The quantities 5 and 15 and 3 and 9 are said to be in proportion.
Oh, got it, Dad. Sorry, Tammy. I doubted you.
Daddy, what if Shelley had given me 6 butterflies out of 15, and I had given her 3 beetles out of 9?
Interesting. Look, 6:15, when simplified further, gives us 2:5, while 3:9 is simplified to give us 1:3. Since the two ratios after simplification are different, the ratio 6:15 is not equal to the ratio 3:9. So, 6 and 15 and 3 and 9 are not in proportion. Come out, children! Look what I've got!
Fish? Mom and I also got fish from the market in the evening.
Wow, what a treat. So much fish. I wonder who got a better deal, Mom or Dad?
Well, I bought 3 kilograms of fish for 30 rupees.
And we got 2 kilograms of fish for 20 rupees.
Dad, how will we know whose purchase is more expensive?
Once again, proportions to the rescue. Notice that we have 2 quantities here: the weights of the fish and the cost of the fish. Remember, always use the same unit to find the ratio of 2 quantities. So, firstly we find the ratio of the weights of the fish, which is 3:2. Then we find the ratio of the cost of the fish, which is rupees 30 is to rupees 20, or 3:2. We notice that both the ratios are equal, and so are proportionate to each other. So, both Mom and I have bought the fish at the same rate.
And Dad, we read it as 3:2 as 30:20, isn't it?
Absolutely.
Wow! I never knew that we could use proportions this way.
Now look closely. When four quantities that are in proportion are taken in an order, then they are called respective terms. The first and fourth terms are called extreme terms, and the second and third terms are called middle terms.
That's nice to know.
Let me check if you two have really understood proportions. Now tell me, do the following ratios form a proportion?
First and foremost, the quantities in the ratio should have the same units, but here the quantities are in centimeters and meters. So, we convert 2 meters into centimeters by multiplying 2 with 100 centimeters. This gives us 200 centimeters.
Good going, son!
So the first ratio is 25 centimeters is to 200 centimeters. On simplification, we get 1:8.
Now, in the second ratio, we convert 4 minutes into seconds by multiplying 4 with 60 seconds. We get 240 seconds.
So the second ratio is 30 seconds is to 240 seconds. On simplification, we get 1:8 again.
Therefore, the ratios 25 centimeters is to 2 meters and 30 seconds is to 4 minutes are in proportion.
Well done, children! I'm so proud of you.
Oh, I love honey. A spoonful a day keeps the doctor away.
Yeah, right. What a reason to have honey.
Dad, I want to gift a bottle of honey to my friend the panda. How much will a 2-kilogram bottle of honey cost?
Well, what is the cost of this 5-kilogram bottle of honey?
It is 750 rupees.
Now, if we get to know the cost of 1 kilogram of honey, we will be able to calculate the cost of 2 kilograms of honey.
That's interesting. Never thought of it that way.
This method of calculating the value of 1 unit and using this value to calculate the value of the required number of units is called the unitary method. Let us understand how to find a solution to Shelley's question. We know the cost of 5 kilograms of honey. So, the cost of 1 kilogram of honey will be 750 divided by 5, which is 150 rupees. Now you know the cost of 1 kilogram of honey. So the cost of 2 kilograms of honey can be found by multiplying 150 rupees with 2.
That's 300 rupees.
Excellent, Shelley.
This is such an interesting method, Dad.
No doubt it is. Now tell me, if the cost of 6 loaves of bread is 72 rupees, then how many loaves will you be able to buy for 24 rupees?
Dad, we can use the unitary method again. All right, so for 24 rupees, the number of loaves we can buy is equal to 6 upon 72 multiplied by 24.
Exactly. So, in 1 rupee, we can buy 6 upon 72 parts of the loaf of bread.
All right, so for 24 rupees, the number of loaves we can buy is equal to 6 upon 72 multiplied by 24. On simplifying further, we find that the answer is 2 loaves. So, for 24 rupees, we'll be able to buy 2 loaves of bread.
Very good, Tammy. Come, let's go out and have some ice cream. We'll also buy honey for Shelley's friends on the way to the ice cream parlor.
Congratulations! You have successfully completed this lesson. In this lesson, you learned to determine whether the given ratios are in proportion and also use the unitary method to solve problems.